All right, so today we're going to study sets, so that's kind of a completely different topic from inequalities what we were doing before. So you have to gear into it, but I'll try to combine inequality questions with set theory so that we can kind of still remember, we can still remember inequalities. We won't forget everything. So what I want to learn today is a couple of these operations here. Because dealing with sets, there's a whole host of operations that you have to become familiar with. So intersections of sets, unions of sets, that's what these are called. Here's the intersection, union, this is called the set theoretic difference, set theoretic complement, and the Cartesian product. Okay, these are some operations. And so an example type problem is you'll be faced with something like this, some weird mess of symbols, and you have to interpret that and know how intersections and unions play with each other so that you can simplify an expression like that. Okay, another thing is frequently you'll be faced with two sets and you have to prove that they're equal. And to prove that two sets are equal, I'll go over this later. Basically, it just means that one set's contained in the other, like A is contained in B, but also that B is contained in A. So for example, here's an example of a problem that you might be asked to prove, an equality of sets. This is called a set identity. You'll be asked to prove a set identity like this. And a good approach for it, well, basically the only approach is to prove a double inclusion. So we'll go over that. Okay, I think this is one of the quiz problems, so I was just explaining earlier. Okay, so let's talk about sets. And let me clear the annotations off the screen. All right, so set theory. So ultimately what a set is there's a lot of, there is a definition of a set, but I think that in this course, going into that is going to be a big mess. It's just going to, it's a bit too advanced. So instead, we'll give a naive definition. And that just means that it's a definition that isn't too formal. So it's just a set is a collection of objects. That's all that we can say today. Or probably for a long time. You won't learn for multiple years what a set is. And so people use curly braces. So you put an open brace like this, and inside the brace you put stuff, you can put all the elements of the set. So for example, if the elements of the set, and I say collection of objects, it can really be anything. So I can put 7, it's a number, that counts as an object. I can put a heart, that counts as an object. I can put, I don't know, a question mark, that counts as an object. Another thing that counts as an object is a set. A set itself is an object. So I can put a set inside a set. So I can put a set consisting of 1, 2, and 3. Sets are objects too. So this is a set with 4 elements. This set has 4 elements. The things in this set, and you might look at it and say, no, it has 6 elements, right? It has 7, heart, question mark, 1, 2, and 3. But that's not quite right. It actually has 4 elements, 7, heart, question mark, and this set. Those are the 4 elements of this set, which is confusing, but there's a difference between a subset and an element. Okay, so let's see. If you can't list out the elements, in this case I only had 4 elements, if you can't list out the elements, another way to do it is to describe the set with something called set builder notation. So for example, you've all seen this interval. From your high school class, you might have seen an interval like this. This represents the set of real numbers that are bigger than or equal to 1 and strictly less than 3. So it doesn't include 3. And see, because this set is infinite, I have to use this thing called set builder notation, where instead of listing the elements the way I did in the first example, I just describe the collection of all the elements, okay? So this is called set builder notation. Or set building, let's say. Okay? Yeah, and then somebody says the elements have to be distinct. So that's another thing I'll point out, is that you ignore repetition. If I have a set, you ignore repetition and you ignore ordering. Like if I rearranged the elements of this set here, like if I put the heart before the 7, it would have been the same set. So for example, if I have the set 1, 2, 1, that's the same as the set 1, 2 because of the repetition. The 1 here and the 1 here, since it's duplicate, you don't write it twice. That's just a quirk of set notation. And ordering doesn't matter. So 1, 2, 1 comma 2 is the same as 2 comma 1. Those are the same set, okay? All right, so with that all in mind about how, oh, actually no, before I start the poll, let me tell you a little bit about subsets. A subset, basically what this means is we use this notation, A is a subset of B, and this just means that every element of A is an element of B. So a simple picture of what that looks like, what a subset looks like, is here's A and here's B. Every element that's in A, every element of A is also an element of B. B has A contained inside of it. So mathematically, the way you say that is if X is an element of A, then it also must be an element of B, because every element of A is contained as a member of B. Okay, so this is the definition of a subset. Okay, and I'll instead of giving you examples, let me see, because you're supposed to read this in advance. Let me see if you know, before I give you some examples, how to kind of work with this type of notation. So maybe I'll leave up here the definition of a subset, and let's start the poll. So if X is not a subset of B, which of the following statements can we conclude? So there's a poll. I hope you all saw the pop-up. Okay, and take some time to think about it. You don't have to answer immediately. I'll give you like 2 minutes to work on it. And I'll try to look at the chat in that time. So if X is not a subset of Y, what can you conclude about these two sets? And you can pick more than one answer if you want. Are elements and objects interchangeable? Yes, I use the word object and element basically interchangeable for now. I'll let you know if that changes. I don't think it will. Object and element are like the same thing. Yes, it's like an array inside an array. If you're in CS, the difference between a subset and an element has to be absolutely clear to you. If it isn't, then your computer, it is clear to your computer, so your computer is not going to be able to interpret what you type in correctly. And that's the most I can say about CS. My knowledge is really limited. In Python, there are sets. You could use tuples. Yes, tuples and sets are different. I will talk about tuples shortly. Okay, a minute and 15 seconds. That's 45 more seconds. Please vote. Please vote. Almost all the classes voted, so I'm just waiting on the last 20 people, 30 people. Yeah, so maybe I can say something here. The set 1, 0 is a subset of the set 2, 1, or maybe 2, 0, 1. This is an example of subsets. All right, 10 seconds I'll give you, but almost everyone's answered. So this symbol here, note that when I have two real numbers, so there's inequality where A is less than or equal to B, and now we're talking about subsets where capital A is contained in capital B. Okay, that's it for the poll for now. Let's see how it goes or how it went. Okay, so people are answering C here. Let's see, good. That is, yeah, I think C is the correct answer, but a lot of people answered A. So let me go over why A isn't the correct answer yet. It's definitely C. Why is that? Let me explain. So okay. So let me give you an example. Let's say I have the set X as, let's do the same one I did before, 1, 0, and Y is the set 2, 1, 2, 0, 1, I like that, right? Then X is a subset of Y, right? Oh, sorry, I'm supposed to give an example where X is not a subset of Y. So maybe I'll do, instead of 0 there, I'll do 3. So there we go. So x is here, x is not a subset of y. Okay, and the reason for that is that, well, what does subset mean? What I said earlier, subset means that if x is an element of A, then x is an element of B. That's the definition of subset. So I have to check that every element of A, another way to put it, is every element of A is also an element of B. Right, so I have to look at this set and say, is every element of X also an element of B? So I look at 1, and yeah, it's an element of, sorry, in this case it's X and Y. So I look at 1, and 1 is an element of Y. Then I look at 3, and 3 is not an element of Y. So it's not a subset. So you can see why C is true, but why is A false, right? A is saying that every element of each element of X, is not an element of Y. And that's actually not true. Every element of X is not in Y, right? A would say that A means that if X is in X, then X is not in Y. And that's simply not true, right? For example, I could have little x to be 1, and 1 is in Y. You see? Whoops. Sorry, that was Siri. Okay, there is some element Y which is not in X. I see. So here's another example. Here's an example of where X is a subset of, can someone give me an example of D? There's an element of Y which is not in X. So X is a subset of Y, but there is some element Y which is not in X. Does anybody have an example for this? An example of a set X, of sets X and Y. Yeah, good. Daniel gave an example. So X is 1, 2, 3, good. And Y is 1, 2, 3, 4. So in this case, yeah, 4 is an element of Y that's not in X. And yet X is still a subset of Y. So D isn't true, right? Okay. Okay, yes. Good. Now, what do I want to say next? What's the next question? Yes. We're going to think about a couple common sets that we're going to see a lot. So the first one, so some important sets that we'll work with a lot. So there's the natural numbers. We use bold lettering for that. So the natural numbers is what is the set of all positive integers. So 1, 2, 3, 4, 5, and so on. Okay. Then there's Z, the set of all positive integers and negative integers, and 0. So let's write 0 and then plus minus 1, plus minus 2, plus minus 3. And see how I have to use, I have to list the elements, but once the pattern is apparent, I just put dot, dot, dot. That's really the only way you can describe infinite sets, is by using dot, dot, dot eventually. There's the real numbers, and this is hard to describe aside from just saying it's the set of real numbers. So all I can say is that this is the set of real numbers. It's hard to describe the real numbers set theoretically without going into a lot of technical stuff from an advanced course. So I'll just say it like this. And an example would be 1 is a real number, pi is a real number, 3 over 4 is a real number, and so on. Oh yes, there's another set that's really important as well. I'll make some space for it. It's Q, which stands for quotient, which stands for rational numbers. So I take a quotient of two integers. So instead of all fractions where the numerator is an integer, well, both a and b are integers, but b has to be non-zero, otherwise I cannot divide. So these all have names, I should say. N is the natural numbers. Z is the set of integers. There's some German reason why we use Z for that. Q is the, I'll stop the poll. Q is the rational numbers. Okay, now there's one more important set I want to show you. Whoops. And it's smaller than all these sets. It's, you're probably thinking the empty set. You're right. It's the empty set. So this is the set that has nothing in it. Empty set, no elements. And this is just something that comes up a lot. We're going to see that sometimes you have two sets that have no intersection. They don't have any elements in common. That means that their intersection is the empty set. So we're going to work on problems like that. So, okay, just a little poll question using all these notations. Which of the following are true? I'll try to keep the rest on the screen. Which of the following are true? Of these 6 options, and you can pick, obviously you can pick more than one. I'll give you 2 minutes for this one as well. Kanish says there's one more, there's C, the complex numbers. Well, there's more than that. There's way more than that. It's not just the complex numbers, there's the quaternions, there's octonions, there's also numbers between Q and R. There's also numbers between Z and Q. There's numbers between all of these. So it doesn't stop anywhere. There's infinitely many examples you can give. So which of the following are true? So I have a bunch of weird set theoretic statements. But the thing with set theoretic statements is that they always mean exactly one thing. And it's kind of fun to try to figure out what it means, right? And even if the notation's strange, it still means something unambiguous. That's the miracle of set theory. So what is D? Well, I'll take it up after. I'll give you another 60 seconds or you know, maybe another 2 minutes if people need the time. So you have to know what subset means, but you have to know what all these symbols mean too. Yeah, there are multiple answers. You should be able to select multiple answers. Can you select only one answer? Can you select more than one answer? Okay, good. Okay, good, thank you. I thought I'd set it up correctly. In D, what's the other letter? Is it Q? Yeah, that's a Q. That's the way I write my Qs. And if you get really fast, you end up doing that, something like that, which looks like empty set, which can be confusing. Yeah, I guess it is like an O with an H in it. I never thought of it that way. I thought of it as a Q with kind of like a bold here. If I had to write it as nicely as possible, I guess I would write it like this. I don't know. Does that look like a Q? That's probably if I had to write it. All right, so that's 2.5 minutes. Almost everyone answered. So I'm gonna end the poll. So how'd that go? So a lot of people answered A, that the Z is a subset of R. Yeah, that's definitely correct. Every integer is a real number. Actually, all these inclusions, all these sets here, there's a natural ordering to them. The empty set is contained in the natural numbers because technically the natural numbers as a subset has nothing in it. I can go over that more later, but you should know that the empty set is a subset of any other set. The natural numbers is, every natural number is an integer. Every integer is a rational number because the denominator is just 1. Every rational number is a real number. So this is kind of an ordering. You can see that Z is a subset of the real numbers because it's a subset of Q. Okay. So yeah, A is definitely correct. What else was said there? So B, huh? Okay. So somebody tell me this. How many elements are in this set? 1, 2, 3, or infinitely many? How many elements are here? 1, right? Right. It's this set here has 1 element, and its element is an infinite set, which is subtle, but it only has 1 element, right? And is that element, this set, Z, is that an element of the real numbers, right? Right? If this was true, it would be like saying that, sorry, here, maybe I'll write it out. This is, I'll make some more space. B is like saying that the set of integers is an element of the real numbers. That's not true. Every integer is a real number, but the set of all integers, that's not a real number, that's a set. So this statement's actually false. Okay. C, people said was true. Yes, the real number is a subset of itself. Every set is a subset of itself, correct? D, let's see. D had a lot of answers. A lot of people think D is true. Let's see. I see. So let me erase my doodles here. For this one, this is like saying, yeah. So how many, okay, here, let's put it this way. How many elements are in this set? How many elements are in this set? 2, right? How many elements are in this set? Z. Infinite. Yeah. Infinite. 1. Infinite. Okay, good. Yeah. Let's look at this example. Let's look at the definition, right? It has infinitely many elements in it, right? 1 for every integer. So here I have a set that's infinite. And here I have a set on the bigger side, I have a set with only 2 elements. Obviously, an infinite set cannot be contained in a set with 2 elements, right? So that's one way to see why. So this one's false. Okay. Ooh, this is a tricky one. So fewer people answered E, and I think you'd be correct. Here, the empty set has nothing in it. And on the other hand, this thing is a set with the empty set in it. So this has 1 element, while this has no elements. So you can kind of count elements to see, sometimes that works. So this one's false. And then the last one, F. Okay, almost half the class answered F. Oh, that's because it's true. Yes, it is true. The empty set is a subset of anything. Empty set is a subset of X for any set X. Every set contains the empty set. Okay. How come B is false? Okay. B is false. It's true that the set of integer, okay. Okay, well, let's see what happens, right? Suppose that it was true, right? If this was a true statement, that the set containing the integers is contained in the set of real numbers, what does subset mean, right? Subset means every element of the smaller thing is also an element of the bigger thing. So this means that, so if this set inclusion held, then every element of the smaller set would be an element of the bigger set. Now, the set of integers is an element of the smaller set. So this tells me that Z is an element of the real numbers, right? It's a member of the real numbers. And that's not true, right? Can someone explain why this set is not an element of the real numbers? I can give you another example. Tell me this. Is this set 1, 2, 3, my favorite set, is this an element of the real numbers? Is this true? People saying yes, people saying yes, people saying yes. Some people saying no. Absolutely no, it's not. It's not, right? Element means that it represents a single element of that set, right? This is false. This one's also false, right? Here what we can say is that 1 is an element of R. Let's say 5 is an element of R. Pi is an element of R. For example, all these numbers individually are elements of R, but a set of numbers is not an element of R. It's a subset of R, right? 1, 2, 3 is a collection of real numbers, so it's a subset of the real numbers. That's a true statement. There's a difference between element and subset. Element means a single thing in there. Subset means a collection of things in there. It could be a collection of single things, right? Another thing that's true is that all of these are true. I'll say true. All of these are true. The set containing 1 is a subset of the real numbers. Okay. There's somebody saying, I don't get why this has 2 elements. Well, think of it like this. If I give you a set like this, 4, 5, this has 2 elements. Right? It's just a list of the 2 things that are in the set. And I can put anything there. I could put the set consisting of a set 1, 2, 3, and another set 1, 3. How many elements does this have? This has 2 elements also. I have another question for you later. This has 2 elements also. 1, and one of the elements is a set, but that's not a problem. You can have sets or objects. A set can be an element of another set. It can also be a subset of another set. So there's 2 elements in this set. In this example, it doesn't matter if Z is infinite or Q is infinite. Each one is an element of the set. It's not a subset of the set. Can somebody give me an example of a set X such that Z is an element of X and the set containing Z is a subset of X? No, that's not good. Z is an element of X. And let's say what's a good example here? Maybe 2. No. So example of a set X such that Z is an element of X. And let me think of an example off the top of my head. Maybe that the set containing Z is also an element of X. Here we go. Can someone give me an example of this set? Yeah, I think Tamsil and Muhammad got it. You could take X to be the set containing Z and also the set containing Z. This is a set with 2 elements in it. Okay, here, let me try to give you an example. I wish I brought something with me, but I don't have anything that I can show you. But I can try to draw a picture. Okay, let me try to draw a picture. Here's a box. Okay, here's a box. Okay, somebody's drawing on my screen. Here's a box, and in it is two more boxes. And in this first box are a 1, a 2, a 3, and a 4. And the second box has a 1, a 2, and a 3. Okay. How many elements are in this set? Well, here, let me add one more maybe. One more box inside. Imagine a shoe box. that has more shoe boxes inside it. Maybe like that. 3, okay? 3, right? There are 3 elements in the set. And it's these 3 boxes. You only look one level in. You could think of it like that. The elements of a set are just the things that are in it, not the things that are in the things that are in it, right? Because this set has a box in it. It doesn't matter how many things are in this box. This sub box or subset is what we say. It doesn't matter how many things are in this smaller box. What matters is the number of boxes total. And that's 3. Does that make sense? And I could have put another box inside this one, 2 more boxes. And each one of those boxes could have had 2 more boxes inside them. And it doesn't change anything. It makes it, this total box still has only 3 elements in it. Okay? So this only has 3 elements. Okay, does that clear it up? This X has a box in it with infinitely many things in it. And it has another box in it. And this box only has 1 thing in it. And the thing in that box is another box that has infinitely many things in it. So there's multiple layers here. But what's interesting is that this notation is completely unambiguous. So this box, if you view it like that, it's not a subset of, this box itself isn't a subset. It's an element in this case. A subset would be a collection, a set of things inside. So here's a couple of examples of true statements. We're really falling behind here. An example of a true statement would be Z is an X. That's how we engineer this example. But also that the set containing Z is an element of X. That's what we said earlier. But another thing that's true, sorry, X. Another thing that's true is that the set containing the set containing Z, is this an element of X or is it a subset of X? Is it an element or a subset? What does C mean? Does C mean an element or a subset? Okay, it's a subset. It's actually a subset. And the reason it's a subset is because this is a set with 1 element in it, right? And that 1 element, and so I have to check that every element of here is also an element of X. And it is. This thing, whatever it is, it doesn't matter that it looks weird, whatever it is an element of X, right? There it is. So this is a subset of X. All of these are true statements. So you can say that the set containing Z is an element of X. That's one way you would put it in words. Okay. If you're still confused about that, you can always come to my office hours and ask me. I want to move on to another polling question because I don't want to push this off too much. So here's another thing involving unions. So I should have said something more about unions and set theoretic operations. I didn't get to say anything. I'll put the poll up because, oh, shoot. Here's the poll. So if X is not in the union of A and B, so this is something from the readings. So maybe I can go over it after the poll. If X is not in the union of A and B, then which of the statements there can we conclude? Right? This is from the readings. This means set theoretic difference. Okay, a minute's passed. Yeah, or means that either situation can be satisfied. Here's an example of or. If I say Asan has a cat, or no, let's say it like this. Asan has a millionaire, or sorry, is, I don't have a millionaire. Asan is a millionaire. Or Asan has a cat. This statement is true. Right? Because this first one isn't correct, right? The second one is correct, and only one of them has to be correct for an or statement to evaluate to true. Another one that is correct would be Asan is teaching Math 102. Asan teaches Math 102. Or Asan teaches, or sorry, Asan, maybe let's do the cat one again. You don't know the other course I'm teaching. This statement, also true, because both statements are true. Okay, well, that was 3 minutes. Let me end. Oh, and almost everyone answered, so let's end the poll. So everybody is answering, oh, well, a majority is answering C for this one. Okay, so let's go through this. Let's draw a picture of the union. In fact, I didn't even show you what the union was. I just relied on the homework. So there's what the union is. A union B is the set of elements of it's the set of elements such that X is an element of A, or X is an element of B. And or means what I was writing here, that at least one of the statements must be true. Both could be true, but only one needs to be true. And yes, the polls are only for participation, and they're not even being marked right now. So yeah, so don't worry about that. So this is what union is. If you had to draw a picture, let's say A and B, just for concreteness, were contained in this box. So A is here, and this is a classic picture. A is here, and B is here. Then A union B would be the set of all things that are in A or in B, and they could be in both. So they're allowed to be in this intersection. It doesn't matter that there's overlap. So here are all the elements in A, and here are all the elements in B. That's what the union means. So if X is not in this union, that's what I'm assuming. If X is not in the union, then it must be somewhere outside. So X could be here. As you can see, X is neither in A, nor is it in B. It's in neither of them. So X is not in A, and X is not in B. So it's C. C is the right answer. Okay, any questions about this one? Any questions about this one? No, no questions. Okay, so running out of time. Oh, I had a problem to do, and since I didn't give you the problem, because yeah, I didn't get time to do the problem. We only have 10 minutes left. Let's see. Here is, yeah. Let's skip this one. Let's do this one here. So here's a problem I wanted to give you, maybe 10 minutes to solve, but we only have 10 minutes left. So instead, what let's do is here's two problems. The first one, you should definitely try it. Maybe I'll take it up on Monday, but I think it'll be fun to try this second one in 10 minutes. I'll give you 5 minutes to think about it, and then I'll take it up in the last 5 minutes of class, okay? So let's try this one right now. I called it extra, but I think based on what we were talking about earlier, let's do this one for now, the second one. Okay, I'll give you 5 minutes to work on this, and then I'll take it up. Okay, people. So how many elements are in this set? And you're gonna like this problem. So it's a big, crazy thing. I don't want to say much about it. Just look at this. One thing I should point out though is that there's a Cartesian product. Oops, sorry. Oops, what did I do? There's a Cartesian product here. An X. There's one here and here. There's a lot of them. What does that mean? That means tuples. Somebody was saying in the chat earlier. So I'll block the first question because let's not worry about that one for now. But yeah, Cartesian products. Let me explain this and then I'll give you a few minutes to think about the problem. Cartesian products. If I take a set A and another set B, what this product means is it's the set of all pairs of elements of A and elements of B. So the ordering matters. The element of A has to come first, and the element of B has to come second. So the ordering matters. These are called ordered pairs. So this is called a Cartesian product, or it's also known as a product set. Okay, and don't say the answer in the chat, please, people. Do not say the answer. In a few minutes, you can say the answer. So let me give you an example. If I give you the set A, B, C, yeah, let's say that, cross with the element, the set 1, 2, this Cartesian product represents the set of all pairs of elements. So it's going to be A1, B1, C1, because I can insert anything from A in the first coordinate and anything in B in the second coordinate, and I have to list all of them. So then the other possibilities are A2, B2, and C2. These are all the elements of the set because I paired up all of them. And it kind of makes sense. There were three choices for the first set and 2 choices for the second set. So it makes sense that there are 6 elements total because it's 3 times 2. Okay. So in 1 minute, I'll take up this problem. You don't have to list all the elements of it the way that I did in this example. You don't have to list all the elements to solve this problem. Tricky problem. And you have to know how open and closed brackets work, right? To do this problem. There's a lot of brackets, and if you're in CS, this brackets shouldn't be you have to learn how to interpret brackets correctly. Okay. Oh, in a second, I'll take up the answer. Why should I'm not going to scroll up yet because that would block the question away. So I have to leave it like this. Oh, you want to see the other problem? You can see that if you want and write it down and take it up later. Okay, here. Okay, let's take it up. So how many, can you put your answer in the chat? 4, 1, 3, 1, 5, 0, 1, 1, 5, some 0, some 1, some, okay. Interesting. Let's try to identify what A and B are here. Because when you have a Cartesian product, it's a set of all element pairs where the first of the pair is from A and the second of the pair is from B. So what are A and B? I have to identify that. And so there's an open brace here. So I have to look for the corresponding closed brace, right? There's open, 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 right? So let's see here. This open closes, oh boy, why did I do this? This open, we have to see where it closes. This one closes empty set, comma, comma, empty set. So this one closes here. So maybe I'll do it like this. Okay, see what's going on? And this set looks like it opens and closes like this. Ah, so this, oh no, did I do it wrong? Maybe there aren't enough braces. I might have, let's try again. Oh, this makes sense. Here we go. There we go. Oh, yeah, you're right. It is missing the last bracket. So maybe I should have put a bracket here. Okay, so that explains why the problem was hard. Here we go. No, that wasn't a trick question. That was a legit typo. So my computer wouldn't have compiled that. Okay, but if I insert that brace, is it clear now what is it clear now how many elements this set has? How many elements does it have? Ooh, the answer is 0. There's no elements. Right? And the reason there's no elements is because here's A and here's B. So if A cross B is the set, oh, sorry. Here's A, oh, what's going on? Here's A and here's B. So it's a set of all pairs where the first element comes from this A here, and the second of the tuple comes from the empty set, and there's nothing in the empty set. So there's nothing to put in the second coordinate. So I can put whatever I want in the first coordinate, but in the second coordinate, I can't put anything. There's nothing to put there. So there's just no possible pairs. So there's 0 elements in this set. And an additional layer to the problem was that I made a typo. So that obviously is going to make the problem impossible to solve if I make mistakes. So sorry about that. But I hope the way I explained it is clear though. Okay. Big Brian. People are saying Big Brian in the chat. I don't know who Big Brian is. But I don't think that's very nice to Brian. Okay. All right. So that's it for class today. I didn't get to everything I wanted to, so I'll start on Monday again with set theory and functions. Okay.